This is section 8.5, Law of Sides. All right, so this is important key concept. For any triangle ABC, let the lengths of the sides opposite angles ABC and AB and C respectively. Then the law of sines relates the sine of each angle to the length of the opposite side. So sine A, so this is the angle, the leg opposite of this angle is going to be A. Sine B, the leg opposite of this angle is going to be B, and the leg opposite of angle C is going to be C. All right, so this works for any triangle, not just a right triangle. All right, so let's look at problem 1. In triangle ABC, angle A, the measure of angle A equals 48, the measure of angle B equals 93, AC equals 15. To the nearest tenth, what is the length of BC? So this is what we are shown here. This is the information you're given. So let's see the information. All right, so angle B, leg opposite is CA. So we're given that the sine of B over 15, so therefore B is 93, so we can put this as 93, equals the sine of A over, and the leg opposite of that is BC. So this is the ratio that we're working with right here. So when we set it up like that, when you solve for it, you're going to cross multiply. So I'm going to cross multiply here. So I'm going to have BC sine of 93 equals 15 sine of A. And then I'm going to divide each side by sine of 93. Therefore, that's where I get BC equals 15 sine of A. Oh no, sine of A is 48. All right, so this is what I'm left with. So when you solve for it, you're going to BC equals roughly 11.2. So that's the length of BC. So try the got it. So you have to look at this diagram. All right, problem 2. In triangle RST, RT equals 11, ST equals 18, and angle R equals 120. To nearest tenth, what is angle S? So first we want to draw this diagram, and this is what we're given from the information above. So let's look at sine. So we're given this angle, the leg opposite we're also given. So we're also given this side. So what's the angle opposite of RT? It is angle S, which is what we're trying to find. So therefore, we're going to set up our ratios. Sine of 120 over 18 equals sine of S over 11. Now, this is where things get. All right, so we have sine of 120 over 18 equals sine of S over 11. Now, let's cross multiply first. 11 times sine of 120 degrees equals 18 times sine of S. So if I want to find sine of S, I got to divide each side by 18. So then I'm left with 11 sine of 120 over 18 equals sine of S. All right, let me see. All right, so you could do this one of two ways. You could solve this number first, or what you can do, all right, I have sine of S. To solve for S, I need to take the inverse sign. So a lot of people, your books you'll see sine inverse of X. That's the same as saying arc sine of X. These two are the same. The book uses this notation, but I use this one. So I'm going to take the arc sine of 11 sine of 120 degrees over 18 equals S. And when you do all that calculation, you get the measure of S roughly equals 32.0 degrees. So, and this is what the book shows you. Now, I use arcsine. All right, so why don't you try this? Got it down here. All right, problem 3. This one's a little lengthy. Let me see. All right. A ship has been at sea longer than expected and has only enough fuel to safely sail another 42 miles. Port Lighthouse and Covetown Lighthouse are located 40 miles apart along the coast. At sea, the captain cannot determine the distances by observation. The triangle formed by the lighthouses in the ship is shown. Can the ship sail safely to either lighthouse? So, we want to see if this ship can safely sail here and here. So in order to find these distances, we got to use the law of sines. So before we do that, we also got to find out this angle. So when we do that, we get 58 degrees. So let's first look at from Port City. So let me make it a little bigger so you can see. From Port City, we do sine of 58 over 40, because that's from the ship. And then we do sine of 52 over d, because that's the distance we're looking for. All right, so then when we solve for everything, we get d roughly equals 37.16, 37.2. So that's what the distance is right here. So the distance from Covetown, when we do the law of sine, sine of 58 over 40 equals sine of 70 over d, which is this distance here. You get d roughly equals 44.32. So the distance from the Port City Lighthouse is, so the ship can't safely go to the Covetown Lighthouse, but it can safely sail to the Port City Lighthouse because of the numbers that we got here. All right, so why don't you try that? Got it down here. Let me see if you can see it all.